Welcome. Today we're diving into the fascinating world of computers. Computers are everywhere, from our homes to our workplaces and even in our pockets. But did you know that not all computers are the same? In fact, there are two main types, analog and digital computers. Each type has its own unique features and uses. In this video, we'll explore what makes analog and digital computers different, how they work, and where you might encounter them in everyday life. Let's start by understanding what a computer actually is and why these differences matter. A computer is an electronic device that processes data and performs tasks according to a set of instructions. Whether it's calculating numbers, playing music, or controlling machines, computers are designed to make our lives easier and more efficient. But not all computers process information in the same way. The two main types, analog and digital, handle data differently. Understanding these differences helps us appreciate the technology we use every day and recognize the best tool for each job. Computers can be broadly classified into two categories, analog and digital. Each type has its own way of handling information. Analog computers work with continuous data while digital computers process discrete data. This fundamental difference shapes how each type is built, how it operates, and where it's used. In the next scenes, we'll break down these two types and see how they compare. Analog computers are designed to process continuous data. This means they can handle information that changes smoothly over time, like temperature, speed, or pressure. Instead of using numbers, analog computers represent data as physical quantities, such as electrical voltage or mechanical movement. These computers are especially useful for simulating real-world systems, like weather forecasting or flight simulation. Let's look closer at how analog computers work and where you might find them. Analog computers use physical phenomena to model problems. For example, they might use the flow of electricity to represent the flow of water in a pipe. By adjusting voltages, currents, or mechanical parts, analog computers can solve equations and simulate processes in real time. This makes them ideal for tasks that require smooth, ongoing calculations. However, their accuracy depends on the quality of their components and can be affected by noise or interference. Some classic examples of analog computers include the slide rule, used for calculations before digital calculators existed, and the differential analyzer, which solved complex equations using gears and wheels. Even today, devices like speedometers and old-fashioned clocks are forms of analog computers. They measure and display information in a continuous way, making them perfect for certain applications. Imagine a flight simulator used by pilots for training. Analog computers can simulate the changing conditions of flight, like wind speed and direction, by adjusting voltages and mechanical parts. This real-time response makes analog computers valuable in fields where timing and smooth changes are crucial. While digital computers have largely taken over, analog systems are still used in specialized areas. Despite their strengths, analog computers have some limitations. Their accuracy can be affected by noise, temperature changes, and the quality of their components. They are also less flexible than digital computers, making it harder to reprogram them for different tasks. As technology advanced, digital computers became more popular due to their reliability and versatility. Digital computers are the most common type of computer today. They process information in discrete steps using binary code, ones and zeros, to represent data. This approach allows for high accuracy, easy storage, and powerful processing capabilities. Digital computers can be found in everything from smartphones to supercomputers, making them an essential part of modern life. Digital computers use electronic circuits to process data in the form of binary digits or bits. Each bit is either a 0 or a 1. By combining millions or even billions of these bits, digital computers can perform complex calculations, store vast amounts of information, and run a wide variety of programs. This makes them incredibly versatile and reliable for almost any task. Digital computers are all around us. Your laptop, smartphone, and even your smart TV are all examples of digital computers. They can run different types of software, connect to the internet, and help you with everything from work to entertainment. Their flexibility and power have made them the backbone of the digital age. Think about the last time you used a search engine, played a video game, or sent an email. All these activities rely on digital computers. Their ability to process information quickly and accurately makes them perfect for tasks that require precision and speed. From business to education, digital computers are essential tools in our daily lives. Digital computers offer many advantages over analog computers. They are highly accurate, easy to program, and can store and retrieve information quickly. Their reliability and flexibility make them suitable for a wide range of applications, from scientific research to personal use. This is why digital computers have become the standard in most industries. While digital computers are powerful, they do have some limitations. They process information in steps which can make them less effective for tasks that require smooth, continuous changes. Additionally, they rely on binary code, which means they sometimes need to approximate real-world data. Despite these challenges, their benefits far outweigh their drawbacks for most applications. Now that we've explored both types, let's compare analog and digital computers directly. Analog computers handle continuous data and are great for simulating real-world systems. Digital computers, on the other hand, process discrete data and excel at accuracy, speed, and flexibility. Each type has its strengths and ideal uses, depending on the task at hand. One of the biggest differences between analog and digital computers is how they represent data. Analog computers use physical quantities like voltage or movement to model information. Digital computers use binary code, representing data as sequences of zeros and ones. This difference affects everything from how the computers are built to how they solve problems. Analog computers can process data in real time, making them ideal for simulations and control systems. Digital computers, however, can perform billions of calculations per second, making them perfect for tasks that require high speed and accuracy. The choice between analog and digital often depends on whether real-time response or computational power is more important. Digital computers are known for their accuracy and precision, thanks to their use of binary code and error-checking methods. Analog computers, while fast, can be less precise due to physical limitations and interference. For tasks where exact results are critical, digital computers are usually the better choice. Digital computers are highly flexible and can be easily programmed to perform a wide range of tasks. Analog computers, in contrast, are usually built for specific purposes and are harder to reconfigure. This flexibility is one reason why digital computers have become so widespread in modern society. Digital computers can store vast amounts of data in memory chips and hard drives, making it easy to save and retrieve information. Analog computers, on the other hand, have limited storage capabilities and are not designed for handling large datasets. This makes digital computers the go-to choice for data-heavy applications. Analog computers can be expensive to build and maintain, especially as their components wear out over time. Digital computers benefit from mass production and standardized parts, making them more affordable and easier to repair or upgrade. This cost advantage has helped digital computers become the dominant type in most fields. Analog computers often consume less energy for certain tasks, especially in real-time control systems. Digital computers, while powerful, can use more energy, particularly when handling large computations. However, advances in technology are making digital computers more energy efficient every year. Digital computers are generally more reliable and durable than analog computers. Their standardized components and error correction features help prevent failures and data loss. Analog computers, with their moving parts and sensitivity to environmental factors, require more maintenance to stay in top condition. Digital computers offer user-friendly interfaces such as graphical screens and touch controls, making them accessible to everyone. Analog computers typically have dials, switches, or gauges, which can be harder to use and understand. This ease of use is another reason digital computers are so popular. Some systems combine the strengths of both analog and digital computers. These hybrid computers use analog components for real-time data processing and digital parts for storage and complex calculations. This approach is common in scientific and industrial applications where both speed and accuracy are needed. While digital computers dominate today, analog computers are still used in specialized fields. For example, they play a role in scientific research, engineering simulations, and certain types of instrumentation. Their ability to handle real-time, continuous data keeps them relevant in niche applications. Digital computers continue to evolve, becoming faster, smaller, and more powerful. Innovations like quantum computing and artificial intelligence are pushing the boundaries of what's possible. As technology advances, digital computers will play an even bigger role in shaping our world. When deciding between analog and digital computers, consider the task at hand. If you need real-time simulation or control, an analog or hybrid system might be best. For most other applications, digital computers offer the flexibility, speed, and reliability you need. Understanding these differences helps you make informed choices in technology. To sum up, analog and digital computers each have unique strengths and uses. Analog computers excel at handling continuous real-time data, while digital computers are versatile, accurate, and widely used. Hybrid systems combine the best of both worlds. By understanding these differences, you can better appreciate the technology that powers our modern lives. As technology continues to advance, the line between analog and digital computers may blur even further. New innovations could lead to even more powerful and efficient systems. Staying informed about these developments will help you make the most of the technology around you. Thanks for joining us on this journey through the world of analog and digital computers.